Imagine if we could squeeze the entire history of Earth, spanning billions of years, into just one single day. When would life first appear in this 24-hour timeline? How long would the mighty dinosaurs rule? And how much time have humans actually been around? Mere seconds, or even less. Buckle up, because we're about to take an incredible journey through 5 billion years of Earth's story, compressed into just 24 hours. This is going to blow your mind. If you're as fascinated by our planet's past as I am, make sure to hit that like button and subscribe to the channel for more amazing content like this. Let's dive in. It's 0 hour, the very start of our 24-hour clock. A brand new star is born, one that will one day be known as the Sun. Surrounding it is a massive cloud of dust and gas, the leftovers of an ancient star that exploded long ago. Within this swirling cloud, a small clump of dust begins to form. It grows bigger and bigger until it takes shape as a young planet, our Earth. Back then, a day on Earth was incredibly short, lasting only about 6 hours. Over time, the gravitational pull of a soon-to-be-formed moon slows down Earth's spin, stretching out the length of a day to what we know now. Just 40 minutes into our timeline, something huge is approaching Earth. No, it's not an asteroid. It's another planet called Gaia, roughly the size of Mars. Over millions of years, their paths get closer and closer until they finally collide. The impact is catastrophic. Gaia smashes into Earth at an angle, disintegrating completely. The molten debris from both planets mixes together, and over the next few centuries, it clumps into a spherical shape. This is how our moon is born, a constant companion to Earth from this moment on. By 1 hour and 15 minutes, Earth is starting to cool down. Water vapor, released by countless volcanic eruptions, begins to condense in the atmosphere. For the first time, rain falls on the planet. Small puddles form on the surface, though they often evaporate quickly in the intense heat. Over time, these puddles grow into larger bodies of water, the first oceans. The planet is still scorching hot, with temperatures ranging from 104 to 185 degrees Fahrenheit. In some places, there are even lakes of boiling water. This water comes from the rain, volcanic activity releasing gases from deep inside Earth and even from space. Asteroids and comets, packed with ice, crash into Earth, adding to the water supply. Believe it or not, this process still happens today. About 60 to 100 tons of cosmic material fall to Earth every single day. At 1 hour and 52 minutes, something incredible is brewing in these early oceans. Hot streams of volcanic material flow from deep within the Earth into the water, creating natural chemical labs under immense pressure. Here, nature starts experimenting, randomly mixing molecules together. A major breakthrough happens. The first organic molecules, like amino acids, RNA, and proteins, begin to form. Over time, the oceans turn into a kind of primordial soup, full of these building blocks of life. Eventually, structures that can copy themselves appear. By 4 hours and 30 minutes, the first fully formed cell comes into existence. This is it. Life on Earth officially begins. Fast forward to 5 hours and 53 minutes, and the first viruses show up. Around the same time, something big is happening inside the planet. Earth's core splits into 2 parts, a solid inner core and a liquid outer one. The liquid layer starts to rotate around the solid center, creating a magnetic field. This field gives Earth its magnetic poles, which will flip every 200,000 to 300,000 years, or about 5 to 6 seconds on our 24-hour clock. By 11 hours and 13 minutes, primitive life forms called prokaryotes are already forming basic ecosystems. These tiny organisms are super simple, like a one-room house with no separate spaces. One type of prokaryote, called cyanobacteria, starts doing something amazing: photosynthesis. They use sunlight to turn carbon dioxide and water into food, releasing oxygen as a byproduct. This changes Earth's atmosphere forever. At 11 hours and 35 minutes, something called the Great Oxygenation Event happens. Cyanobacteria pump out so much oxygen that it builds up in the air and water as a free gas. For most life forms at the time, this oxygen is like poison. But some bacterial communities have already adapted to use oxygen for energy. They live in rare oxygen pockets, which now start spreading across the planet. By 13 hours and 39 minutes, life fully shifts to using oxygen for energy. At the same time, life starts evolving in new ways. One cell swallows another, but instead of destroying it, the swallowed cell adapts and becomes useful. This partnership, called endosymbiosis, leads to a new kind of cell, the eukaryote. Unlike prokaryotes, which are like a single-room apartment, eukaryotes are more like a big house with separate rooms. They have a nucleus to store genetic information, mitochondria as a power source, and other tiny parts, each with its own job. By 15 hours and 43 minutes, these cells start grouping together, forming the first primitive multicellular life. Just 2 hours later, at 17 hours and 47 minutes, fully developed multicellular organisms appear. The first organism to reproduce sexually, an alga called Bangiomorpha, shows up, along with the first fungi. But at 20 hours and 38 minutes, disaster strikes. Changes in greenhouse gases and ocean currents cause a dramatic shift in climate. The Marinoan glaciation, also known as Snowball Earth, begins. The planet gets covered in ice several miles thick, and temperatures drop to minus 58 degrees Fahrenheit. Most life forms die out, with only a few surviving in ocean hot springs or cracks in the ice. 5 minutes later, at 20 hours and 43 minutes, volcanic activity starts melting the ice, both in the oceans and on land. The surviving organisms spread into new areas, taking advantage of empty spaces. At 21 hours and 2 minutes, life explodes in diversity during what's called the Avalon Explosion. Complex multicellular organisms, known as the Ediacaran biota, emerge. These are mostly soft-bodied creatures with symmetrical shapes, some growing to several inches long. Unlike earlier simple life forms, these creatures come in all sorts of shapes and lifestyles. Just 10 minutes later, at 21 hours and 12 minutes, the Cambrian Explosion kicks off. Life gets even more complex, with the first organisms developing hard body parts. Nature starts experimenting like never before. Trilobites, creatures with hard outer shells, spread through the seas. The ancestors of all vertebrates, animals with backbones, start appearing, like Bacaya, a small creature with a primitive spine. Weird forms like Hallucigenia, covered in spines, and Wiwaxia, with armored plates, also show up. By 21 hours and 27 minutes, the Cambrian Explosion winds down. Around 21 hours and 34 minutes, plants begin to appear on land. These early plants are simple, like mosses, with no roots. They soak up moisture through their whole body. Once they take hold, they start changing the earth itself, producing oxygen and creating new homes for other life forms. By 21 hours and 40 minutes, the first animals crawl onto land. These early pioneers are arthropods, ancestors of today's insects, spiders, and centipedes. As plants cover wet coastal areas, animals follow, looking for food and new places to live. At 21 hours and 50 minutes, the oceans are bursting with life. This is the Devonian period, often called the Age of Fish. The waters are full of diversity, from jawless fish to huge predators like sharks and armored fish. One type of fish, called tiktaalik, starts using its fins to move in shallow water, almost like legs. It's as if it's getting ready to take a giant leap. And at 22 hours and 5 minutes, that leap happens. The first amphibians emerge from the water onto land. Descendants of lobe-finned fish, creatures like Ichthyostega and Acanthostega, have simple legs but still keep fins and features for sensing water vibrations. Though they still need water to reproduce and stay moist, they can hunt and live on land. By 22 hours and 16 minutes, the continents collide to form a massive supercontinent called Pangaea. These collisions create towering mountains, and the climate shifts. The interior of Pangaea becomes dry, while the coasts turn tropical. At 22 hours and 20 minutes, the first reptiles appear. Unlike amphibians, they don't need water to survive, allowing them to spread far and wide. For now, these creatures are small and unremarkable. At 22 hours and 48 minutes, we enter the Triassic period. Some reptiles evolve into the first dinosaurs. They're still small, looking like large lizards, but they have a key difference: an upright stance. Unlike other reptiles, dinosaurs walk with their legs directly under their bodies, making them faster and more agile. They split into two main groups: Saurischians, which include predators like Tyrannosaurus and plant-eaters like Diplodocus, and Ornithischians, which later become giant plant-eaters like Triceratops and Stegosaurus. By 23 hours and 13 minutes, some dinosaurs take a surprising turn. Small predatory dinosaurs, like dromaeosaurs, evolve into the first feathered theropods. One early species, Archaeopteryx, has dinosaur traits like teeth and a long tail, but can also make short flights. Over time, feathers become better suited for flying, wings grow longer, and bodies become more streamlined. A creature called Confuciusornis, with a short tail and beak, is one of the first true birds. Yes, modern birds evolved directly from dinosaurs. At 23 hours and 16 minutes, plants undergo a major change with the appearance of the first flowering plants. Before this, the earth was full of ferns and conifers that reproduced with spores or unprotected seeds. Flowering plants develop flowers and fruits, giving them a huge advantage. Flowers attract pollinators like insects, creating a successful partnership that helps these plants spread across the planet. Life is thriving on land and in the oceans, with no sign of trouble ahead. But at 23 hours and 39 minutes, catastrophe strikes. A massive asteroid, larger than Mount Everest, and about 6 miles wide, crashes into Earth near what is now the Yucatan Peninsula in Mexico. It hits at a speed of 12 miles per second, instantly destroying everything within a 1,000-kilometer radius. The impact creates a crater 20 miles wide, and several miles deep. A huge cloud of dust and debris covers the planet, blocking out the sun. Temperatures skyrocket. Firestorms rage across the land. Forests burn, and ecosystems collapse. The seas boil, and animals die from heat and lack of oxygen. Then, as sunlight is blocked, temperatures drop, leading to global cooling. Plants can't photosynthesize, and food chains break down. Dinosaurs and up to 75% of all species vanish forever in this mass extinction. Storms, tsunamis, earthquakes, and wildfires devastate the planet. After several years, the dust finally settles and sunlight returns. The climate slowly recovers, though it's changed forever. In the aftermath, mammals, small, mostly nocturnal creatures until now, start to take over. Their ability to stay warm, give live birth, and grow fur helps them adapt and become dominant. Some stay on land, others return to the water, and some live in trees. Among them, a special group emerges. By 23 hours and 40 minutes, small animals resembling modern lemurs appear. These nocturnal creatures, called primates, live in trees to find food and avoid predators. One of the earliest primates, Plesiadapis, develops sharp vision, flexible limbs with grasping fingers, and a larger brain for better coordination. At 23 hours and 49 minutes, the first narrow-nosed monkeys show up. And by 23 hours and 58 minutes, something legendary is about to happen on the African continent. Dense forests turn into open savannas, forcing primates to come down from the trees and adapt to life on the ground. This leads to the rise of Sahelanthropus chadensis, one of the first hominids to walk on two legs. Walking upright isn't just a physical change. It frees up their hands for tasks, paving the way for intelligence to grow. In the last minute of our 24-hour history, everything speeds up. At 23 hours, 59 minutes, and 13 seconds, Homo habilis, or handyman, appears. With a larger brain than earlier ancestors, they start using basic tools. At the 24th second of the last minute, Homo erectus emerges with an even bigger brain. Fully adapted to walking upright, they spread out of Africa into Asia and Europe, and they begin experimenting with fire. At the 48th second, Homo heidelbergensis shows up with an even larger brain. They master fire, build shelters, and hunt big animals like mammoths using teamwork and simple tools. 2 seconds later, Homo neanderthalensis appears. They're excellent hunters, highly social, care for their sick, bury their dead, and even develop basic speech. At the 54th second, Homo sapiens, our direct ancestors, emerge in Africa. For a brief time, multiple human species coexist on Earth. At the 58th second, modern humans, Homo sapiens sapiens, begin migrating out of Africa, spreading to other continents. Just a second later, Neanderthals go extinct, though some of their DNA lives on in us through interbreeding. In the final fraction of a second, humans survive a minor ice age. The climate stabilizes, and farming begins. This Neolithic revolution changes everything. People settle down, populations grow, and technology advances rapidly. At the 95th millisecond, the pyramids of Giza are built. Moments later, the first successful steam engine is invented. 5 milliseconds after that, our planet, the precursor to the internet, is created. And now, here we are in the age of the internet and in AI. You're watching this video, learning about Earth's incredible journey, and hopefully hitting that like button. What a ride through history.